Everyone to the channel. Today we discuss our internal paper and there are five questions in our paper we have. First is how is unstructured data analyzed in the context of data science? Provide an example of a data mining activity used to analyze unstructured test data. How can text mining techniques be employed to automate the classification of written complaints? So first we analyzing unstructured data in data science. So unstructured data such as text, images, audio and video lacks a predefined format or schema, making it more complex to analyze than structured data. In data science, analyze unstructured data typically involves transforming it into a structured format that algorithms can process. This often requires techniques such as natural language processing (NLP), computer vision, or audio signal processing depending on the data type. Now, as we consider example of a data mining activity, topic modeling. So one common data mining activity used to analyze unstructured text data is topic modeling. This involves discovering abstract topics within a collection of documents without prior labels. Algorithms like latent Dirichlet allocation or non-negative matrix factorization are frequently employed for this purpose. For example, as input customer reviews from an e-commerce website. So customer get out so we get output as a topic such as delivery time, product quality, or customer service derived from analyzing word occurrence pattern. Now, automating classification of written complaints using text mining techniques. So, to classify written complaints, text mining techniques can be used to identify patterns, extract meaningful features, and assign predefined categories. The process typically involves first is pre-processing the text. So, first steps in pre-processing the text is tokenization. In tokenization, breaking down the text into individual word or phrases. Then after tokenization, stop word removal is coming and removing common words like and or the that don't carry much meaning. Then streaming and lemmatization, reducing words to their root forms. Then vectorization. So vectorization converting text into numerical form using methods like term frequency, inverse document frequency, or word embeddings. Second step is feature extraction. So in feature extraction, first step is extraction keywords, phrases, or sentiment scores from the text. And second, identify entities and relationships. Third steps is classification models. So train machine learning models like logistic regression, naive Bayes, or support vector machines on labeled complaint data. The second step in classification model is use advanced NLP model like BERT, Robert R, and GBT based model for contextual understanding of the text. Now, fourth step is automation. In this, feed new complaints into the trained model to predict categories such as billing issues, product defect, or delivery delay. As example, dataset we take input consumer complaints such as the product was defective and didn't work as described. And second is my bill includes charges I don't recognize. Then workflow, how it works. So first is pre-processing in which convert to lowercase, remove punctuation and tokenize. Second is apply TF-IDF vectorization to represent the text numerical. Then after pre-processing, model training step is coming in which train a naive-Bayes classifier on labeled complaints. Then prediction. So classify new complaints automatically based on the trained model. So we get output as a complaint 1 and as a complaint 2. In complaint 1 we got product issue and in complaint 2 we got billing issue. Now question 2 is coming. Discuss specify methods or technologies that facilitate this process. Given the following complaints, describe the approach, algorithm, or processes for identifying applicable IPC or BNS sections. Theft of my mobile phone by an unknown person at MG Road on 2023 February of 20. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a sear on his face. So to classify the complaint into applicable IPC or BNS sections, a well-defined text mining and natural language processing pipeline can be designed. Here, how it can be accomplished. First, approach. So, approach is the first step of approach is text preposition. Again, in text preposition, first step is tokenization. Split the text into small units, and second step is stop word removal, in which remove common words like and, at, or, that don't add meaning. Third is streaming and lemmatization, reduce words or their roots. Then second step in approach is entity recognition and extraction. So first step in entity recognition and extraction is named entity recognition, in which extract key entities such as crime type, object involved, location, date, and perpetrator description. And then tools like Specie, Stanford, NLP, and Hugging Face transformers are useful here. Now, third step is crime mapping. So develop a mapping of crime types and associate description to relevant IPC or BNS sections. For example, theft, IPC section 378, unknown person committing theft in public space, BNS section X, public safety offense. Now, fourth step is classification models. So train a supervised learning model on labeled complaints to classify text into specify IPC BNS sections. Then use embeddings to understand the context semantics to the text. Then fifth step is rule-based system. So in rule-based system, combine an automatic classifier with a rule-based system that flag key phrases for additional accuracy. Then after approaches, we discuss pipeline in action for the complaint. So first is complaint, then entity extraction. So in which we extract the meaningful insights from the complaint, like crime is theft and object mobile phone, location MG Road, date is 2023, February of 20, then perpetrator, so unknown person, black jacket, scare on fear. Now, second is crime mapping. So match theft to IPC section 378, context, specify, analyzes, identifies public space theft, possible additional sections under BNS or local security laws. Then third is algorithm processes, rule-based filtering, use predefined rules for theft plus public space to infer likely sections. Then second is machine learning model, feed the processed text into a fine-tuned BERT model to predict relevant IPC sections. Then output which we get, applicable IPC section is 378 in case of theft. Then and second additional security section is public safety or theft related causes. Now technology which we use in that, first is NLP libraries, in which is Splicey, then Hugging Face Transformer, and NLTK or TextBot. Second technology is machine learning models, in which logistic regression and BERT is coming, and third is database and crime mapping. Now, third question is, what are suitable data structure and algorithm for addressing the task in the previous question? So addressing the task of automatically identifying applicable IPC or BNS sections from textual complaints involves careful selections of data structure and algorithm. Below are suitable choices for each stage of the task. So data structure, first data structure is dictionary and hash map. Purpose of dictionary is to map crime type, keywords, and contextual details to relevant IPC or BNS sections. For example, crime map is theft and public space theft, BNS section, assault, IPC 351 and 352. Advantage is that enable time complexity for lookup operations. Now, second data structure is try. So purpose is for efficient keyword searches in text, especially for identifying legal times or crime types. Explain example is store crime related phrases like theft, stolen, public space for quick lookup. An advantage is efficient for matching substrings in OM time where MM is length in search term. Third data structure is graph. So purpose is to represent relationships between extracted entities. An example is use a graph where nodes are entities like theft, MG Road, and age denote relationships. Advantage of graph data structure is useful for traversing connected entities to enrich context or identify related sections. Fourth data structure is embedding matrix. So purpose is to store pre-trained word or sentence embeddings for semantic similarity calculation. Example is it represent the complaint as a dense vector to measure similarity with non-legal text vectors. Now, algorithm So first is text preprocessing algorithm, in which first is tokenization, split text into smaller unit, then streaming, normalize word to their root form, then entity recognize algorithm, in which first is named entity recognition, second is algorithm and purpose. Then third algorithm is classification algorithm, in which first is supervised learning, as you can read, so you get idea about that. And second is rule based algorithm. Now third is classification algorithm, and after that fourth is similarity matching algorithm, and after that, graph algorithm is last, in which breadth first search and is coming, and their advantage is useful for multi-entity and multi-relation problems. Now, fourth question is explain how these structures and algorithm can be appeared to efficiently classify to complete in the appropriate IPC or BNS section. So to efficiently classify a complaint into the appropriate IPC or BNS sections, the chosen data structure and algorithm must work together to address different stages of the pipeline. Here, how they can be applied step by step. First is text processing. So, data structure hash map purpose is store mappings for stop words, system limitized words, or token mapping for standard. And second is algorithm. So, tokenization, stop words removal, and streaming. Then efficiency, so hashmap provide lookup for identifying and replacing stop words. Algorithm like streaming and limitization reduce word forms for consistency. For example, as you can see here, you get it easy to understand, right? Second is entity recognition and extraction. So data structure and try. Purpose is efficiently store and search for key prime related terms or phrases. Algorithm named entity recognition efficiency tries enable fast prefix based matching of phrases which can then be used to detect entities like crime type, location, and object. And then example is a try is built with terms like theft, stolen mobile phone, and given the text, the algorithm identifies theft as a crime and mobile phone as an object involved. Data structure graph is purpose represent relationship between entities, and algorithm graphs traversal like breadth first search to find all connected entities. For example, graph theft, M0, and mobile phone. Third is crime mapping, in which data structure hash map is used. Purpose is map extracted crime related terms to relevant IPC and BNS sections. Algorithm is rule based lookup for straightforward matches. Efficiency is time complexity for direct machines. For example, this is the crime map assigned theft IPC 378, assault IPC 351, IPC 352. Crime is theft. Applicable sections is assigned crime map dot get crime result IPC 378. So fourth is classification data structure embedding metrics. Purpose is represent complaints and legal text as dense numerical vectors for semantic understanding. So algorithm is supervised learning or deep learning. Efficiency is pre-trained embedding, reduced training time, and transformer models like BERT capture contextual relationship efficiently. Example is embedded. The phone was stolen at M0 into a vector using BERT. Train a supervised model to predict IPC BNS sections. Now, fifth is output generation. So here data structure, try or mesh purposes organize possible IPC and hierarchical algorithm BFS or rule based filtering to refine and output the best matches. So example, try stores related IPC sections for theft. BSF, BFS explores of the try to suggest IPC 378 and IPC 334. Efficiency advantages. First is pre-processing, entity recognition, crime mapping, and fourth is classification. Now, last question of our paper is what metrics are appropriate for assessing the performance of algorithms used in text mining details the metric that evaluate the effectiveness and accuracy of text mining techniques. So, evaluating the performance of text mining algorithm require metrics that assesses their effectiveness and accuracy in processing and extracting meaningful insights from text. Below are the key metrics commonly used. First is effective metrics. These metrics measure the ability of text mining algorithms to achieve the desired outcomes, such as correctly classifying or extracting relevant information. In effective metrics, precision, recall, and F1 score accuracy is coming. Now, second is metrics for classification problems. So, for classification task, these additional metrics are essential. So, communication metrics, ROC curve, and AUC you can read from the slides. You can easy to understand. Now, third is metric for clustering or topic modeling. So for unsupervised tasks like clustering or topic modeling, this matrix assesses the quality of the generated clusters or topic. Here, first is Silhouette score and perplexity and coherence score is included in the matrix of for clustering or topic modeling. Fourth matrix is metric for text similarity retrieval. So here for tasks involving similarity scoring or information retrieval, this matrix evaluates the algorithm's ability to rank or retrieve relevant text. First is mean reciprocal rank. So definition measure how well a system ranks the first relevant result. So they have a respective formula to find that. Second is blue score. So measure the similarity between generated text and reference text and interpretation. Higher scores indicate better matches. Then third is precision and recall. So the precision and recall calculated over the top k results. Interpretation useful for ranking problems where top results are most relevant. Last metrics for sentiment analysis and entity extraction. So Matthews correlation coefficient, entity level F1 score are included in metric for sentiment analysis or entity extraction. So how we choose right matrix. So there are five criteria to choose right matrix. First is binary classification, then imbalanced data sets, then topic modeling, then information retrieval and entity extraction. So in binary classification, precision, recall, F1 score accuracy is included. And in imbalanced data sets, precision, recall, F1 score accuracy can be misleading, and topic modeling, coherence score, perplexity, and information retrieval, MRP, precision and recall, and last entity extraction, entity level F1, precision and recall. So that all about our internal one paper. So thank you to all.